Then let me introduce the next speaker. It is Ilker Dogan.
Yes.
I hope pronounced it
Yes.
right. From TNO. And the title is Towards Roll-to-Roll Manufacturing of Flexible Perovskite Solar Cells. The floor is yours.
Thank you very much for the introduction, and thanks coming for this presentation. This is the only, probably, I think there's kind of, it's the only talk probably not related to batteries, but I do have a background in batteries, and as TNO, we also work on batteries. I hope this counts, but today it will be on perovskite solar cells. It's on behalf of our perovskite team. I first would like to give some overview about what TNO is. It is the Dutch abbreviation, and in English it stands for Netherlands Organization for Applied Scientific Research. And we consist of 6 main units from defense to ICT for high-tech industry, healthy living, mobility, and energy and materials transition. And in the energy and materials transition, our goal is to develop technologies and concepts to drastically reduce the cost of generating electricity, not only from the sun, but also from the wind, and increase the yield. So for this, in the solar cell part, we are also taking part in a greater consortium that is called Solliance, together with our Belgian partners, IMEC, and several universities and research institutes from Germany, Belgium, and Netherlands. And we have also our materials, equipment, PV producers, and end users partners. Here you can see a non-exhaustive list of partners in the past and currently as well. So this is the outline of my talk. I will briefly give an information about the perovskite PV, development of the flexible perovskite PV, roll-to-roll printing, encapsulation, and with some outlook. Why perovskite PV? It is a very interesting technology because if you look at the PV chart in the NRL, record efficiencies, perovskite PV has a history a little bit longer than a decade. But the efficiency that is reached now is competing with the lab-scale crystalline silicon cells, but it's on the lab scale. The advantage is that it is one of the thin film technologies out there, like OPV, CIGS, or dye-sensitized solar cells, which makes it possible to dissolve the precursors in a solvent and do a solution processing, and hence cure it in the low temperature, which also enables the processing on the flexible substrate. One of the advantages is that it has excellent semiconductor properties and it's very defect tolerant. And because of its rich chemistry, it is possible to tune the stoichiometry and tune the band gap. So it's also possible to make tandem solar cells based on perovskite technology. Here is a typical example what perovskite is. It's actually a crystal structure, and in the nature you can find dozens of crystal materials that is basically grouped, that can be grouped in the perovskite crystal structure. But this one is an organic metal and a halide composition that is photovoltaically active, that can absorb light and turn into the electricity. The most studied type is methylammonium lead iodide, but there are many more combinations possible, including the lead-free perovskites. Here you can see a graph. It's only starting from 2013. The first lab-scale cells were basically way below than 10% in efficiency, and they were alive for, let's say, a few minutes, if not mostly half an hour in the lab scale. But nowadays, months of stability is possible under stressed indoor conditions. And you see here how rapid the development is. It starts from, in 2030, from around 13%, and nowadays we are at 20.1%, and there could be even a new record efficiency is coming sooner as we talk. This is an important graph. You have to be careful. This is a rigid lab-scale cell. And if you want to do the same thing for flexible lab-scale cell, the efficiencies are going a little bit lower, but the trend is there. So there is a big increase in efficiency in short time, with record efficiencies around 24%. If I look into the results for the flexible upscalable that I can find from the literature, they are a little bit different story than what you see here on the small scale cells. The issue is that all these, the cells are processed in the lab scale with state-of-the-art material and solvent systems, and especially the solvent systems